Today we're going to go over one section only, which is section 1.6, is the product and the quotient rules. So what do we have in this section? What does it talk about? We were finding derivatives. So recall from before. Recall, if y equals x to the m, then y prime is mx to the m minus 1. Do you guys remember that? So for example, if y equals x to the fourth, what would y prime be? Is bring the 4 down, x subtract 1. Also, recall the derivative, we used a prime of any number is 0, and the derivative of x is 1. So if we have y equals 2x cubed minus 2x squared plus 5x plus 11, and we would like to find y prime. So to find the derivative for this, we get 6x squared minus 2 times 2, 4x, plus the derivative of this is 5, and the derivative of 11 is 0. And then all we have to do, simplify this by rewriting it with no 0 at the end. Again, y prime is the same as f prime of x. That's just a different way or notation. And another way of saying this is dy, the derivative of y, dx, means with respect to x. These three symbols, they mean the same thing. It's the first derivative or the derivative of the function. If we are given a function like this, x squared times x to the third plus 11, and we are asked to find the derivative of this function, what we can do is multiply it out first. No derivative yet, just distribute this times this and this times this. We get x to the fifth plus 11x squared. Then we can find the derivative. Y prime is 5x to the fourth plus 22x. Now we introduced the product rule. The product rule is here to make things easier for us. And what did the product rule says? It says if you have a product of two functions, y equals f of x times g of x, then what is y prime? Do we find the derivative for each one of them? The answer is no. The product rule says you just multiply it like so twice, and you put a derivative on the first one, derivative on the last one. That's called product rule. And how do we apply this? Let's look at this example. Of course, such an example I'm writing now, you may distribute everything and find the derivative, but later on when we learn more rules, product rule will be needed and it will make things much easier for us. So based on the product rule, it says you write it twice, separate with a plus sign. That's the easiest way to memorize it. Separate with a plus sign. Put a derivative on the first one and a derivative on the last one. And then derivative of this is what? 2x. Derivative of x is 1, and keep the second one the same. Plus, keep this the same. Derivative of this is 4x plus 1 minus 0. Then we need to multiply all of this out. 4x to the third plus 2x squared minus 2x plus 2x squared plus x minus 1 plus 4x to the third plus x squared plus 4x squared plus x. Then all we have to do, combine like terms. This one and this one go together as 8x cubed. This one, this one, this one, this one. That's 4, 8, 9. The x is negative x. This cancel. Minus 1. Another example similar to the previous one, but you try it on your own now. Try this one. So for y prime, we copy twice. We place derivative on the first one and the last one. So then y prime is 1 plus 0, x squared plus x plus 1. This stays the same. 2x plus the derivative of x is 1 plus 0. And I'm sure you can expand this yourself. Another one, 3x minus 9, 3x squared plus 2x plus 11.
Professor, I had a question for the first example that we just...
For the first one, rewrite it. Twice. Derivative for the first one is 3 minus 0. The second one stays the same. First one stays the same. Derivative of this is 6x plus 2. For the second one, there's a squaring there. So the squaring means, notice before we start derivatives, is you multiply this twice. Then y prime, copy it twice. Derivative for the first one, derivative for the last one. And what do we get for that? So y prime is, this one is 3x squared minus 7. Keep this the same. Keep this the same. 3x squared minus 7. And if you like, these two copies are identical. So you can write twice that, twice one of them. Any questions about the product rule?
No.
We have what we call the quotient rule. Quotient rule says if y equals f of x over g of x, then y prime is given as f of x derivative times g of x minus f of x times g prime of x over g of x squared. Look at an example. So how do we do this one? Quotient rule, of course. We start with quotient rule. It says you take the numerator, find the derivative for that, times the denominator, minus take the numerator times the derivative of the denominator. And don't forget to square the denominator. So then y prime, we keep the denominator the same. Derivative of x plus 1 is 1 plus 0, which is 1, times the x squared plus 4, minus, keep this the same, derivative of this is 2x. Then we always keep the denominator the same. We don't have to expand this. 1 times the x squared plus 4 is x squared plus 4 minus 2x squared. I'm distributing this and distributing this, minus 2x. Now in the numerator we combine like terms, negative x squared minus 2x plus 4 divided by x squared plus 4 all squared. Another example, you can go over this now. Y prime is the top one derivative times the denominator minus the top one times the derivative of the denominator over the denominator square. Derivative of x squared is 2x times x plus 2. This stays the same. Derivative of this is 1. Distribute now 2x by x, 2x squared. 2x by 2, 4x, minus x squared over x plus 2 all squared. Then y prime is x squared plus 4x all divided by x plus 2 all squared.
Can we have an example of like a radical equation?
We're not there yet.
Oh, okay.
Next one, y equals 1 over t plus 5. T is like an x, just different variable. Try this one. I'm writing another one. When you finish the first one, try this one as well. First one, y prime, we take the top one derivative times the bottom one minus the top one times the derivative of the bottom one over the denominator square. Then y prime equals derivative of 1 is 0 minus 1 times the derivative of t is 1 plus 0 0 times anything is 0, so it's negative 1 on the top and t plus 5 square in the bottom. For the next one, we again use quotient rule. Numerator, derivative times the denominator minus and now we need to find the derivative for the first one. 6t squared, sorry, 6t plus 2 times this minus this stays the same times the derivative of this, negative 2t plus 4. Multiply that out. There's a minus sign. I usually open a bracket and distribute these things out. Minus 6t to the third plus 12t squared, 4t squared plus 8t plus 2t minus 4. Then y prime, keep the denominator the same. We combine like terms on the top. And before we do that, here, this stays the same for now. Like terms with these two is 22t squared. These two, 14t plus 2. Distribute the negative sign in. These two is 8, so minus 8t squared, 10t plus 4. One last step. This cancels this. These two together. 14t squared plus 4t plus 6 over negative t squared plus 4t plus 1 all square. That would be the final answer. How do we apply that in business? So we let C of X, or define it as the cost of producing X items or units. Then we can find two things here. The first one is called the average cost, which is C of X divided by X. And the other one is the rate at which the average cost changing at X equals A is given by C of X over X derivative evaluated, then substitute X equals A. So two things here, the average cost and the rate. Average cost and the rate. Same for the profit function P of X and the revenue function R of X. To apply this to an example, company found out that the total cost in dollars for producing X bottles of barbecue sauce is given by $3.75 plus 0.75x to the 3/4. Find the rate at which the average cost changing when 81 bottles of barbecue sauce have been produced. I recommend you try it on your own first. So they want us to find the rate at which the average cost changing when 81 bottles for the barbecue sauce have been produced. So what they give us here, or they give us a function c of x, the cost. First thing is the average cost. We defined it earlier to be c of x over x itself. And c of x is given to us 375 plus 0.75 x to the 3/4 all over x. Let's call this a function in x, f of x. We need to find the rate at x equals 81. They give us 81 bottles. So how do you find the rate? To find the rate, we defined it earlier as the derivative of this, which is basically the derivative of f of x. So how are we going to find the derivative of f of x? We use quotient rule. So the quotient rule said you take the top one derivative times the denominator minus, keep the numerator the same, times the derivative of the denominator over the denominator square. So now, remember that's f prime of x, f prime of x. Derivative of 375 is 0 plus 0.75, bring the 3/4 down, times, and subtract 1 from 3/4. 3/4 minus 1 is negative 1/4. All that get multiplied by x minus, this stays the same, and the derivative of x is 1. Denominator stays the same. So now, after we do this, we can substitute x by 81, and that would be 0.75 times 3/4 of 81 to the negative 1/4. All that get multiplied by 81 minus 375 plus 0.75, 81 to the 3/4, 81 square. Now it's the right time, if you have a calculator, to take it out and try to calculate this on the calculator. Let's see what you guys gonna get. So if we calculate this on the calculator, the answer would be about negative, in the dollar of course, 0.0579 per each bottle. Make sure you got the same answer.